Mechanical properties of solid and fluids. Elasticity. It is a property of the material to resist the deformation, so steel is more elastic than rubber. Stress. Internal restoring force upon area of cross sections F upon A. When a body is subjected to a deforming force, the restoring force developed per unit area is known as stress. Different type of stress. Longitudinal stress. The restoring force acting per unit area along the length of the body is called longitudinal stress. Tensile stress. When a cylinder is stretched by two equal force applied normal to its cross sectional area, the restoring force per unit area developed in this case is called tensile stress. Compressive stress. Tangential or shearing stress. The restoring force per unit area developed due to applied tangential force parallel to the cross sectional area is called tangential or shearing stress. Now, a strain. Change in size of the body upon original size of the body. Longitudinal strain. Change in length of the body upon initial length of the body. Del L upon L. Shear strain. Tan phi is equal to L upon capital L, or phi is equal to a small l upon capital L. Displacement of upper face upon distance between two faces. A stress strain graph. A stress, a strain, a stress, a strain, a stress, ultimate strength, breaking point. This type of material are called ductile. This type of material are called brittle material. Hooke's law. For a small deformations, the stress developed in body is directly proportional to the strain of the body. That is, a stress is directly proportional to strain. A stress is equal to K a strain. K is equal to a stress upon a strain, where K is equal to a constant called modulus of elasticity. SI unit of K is Newton per meter square and dimensions is ml minus 1 t minus 2. Elastic after effect. The temporary delay in regaining the original configurations by an elastic object when the deforming force are removed in is called elastic after effect. Elastic fatigue. Due to repeated alternate deforming forces on an elastic body, its behavior become less elastic is called elastic fatigue. Elastomer. Substance like tissue of aorta, rubber, etc., which can be stretched to cause large strain, are called elastomers. Figure shows a stress-strain curve for the elastic tissue of aorta, the large tube vessels carrying blood from the heart. A strain, a stress 10 to power 6 Newton meter minus 2. variations in elasticity, effect of temperature. In general, elasticity decreases as the temperature increases. On any link that is on alternate heating and cooling, elasticity decreases. Effect of impurities. If the impurities is more elastic, the elasticity of the material increases. If the impurity is more plastic, less elastic, the elasticity of material decreases. Elastic relaxations time. The time delay in restoring the original form after removing of the deforming force is called elastic relaxations time. For phosphor, bronze, silver and gold, the time is negligible or small. For quartz it is minimum and for glass it is high. Elastic modules. Elastic modules. The ratio of stress and strain is called modules of elasticity. Young's modulus Y is equal to longitudinal stress upon longitudinal strain. Sigma upon E is equal to F upon A upon del L upon L is equal to F into L upon A into del L. Young's modulus of an ideal rigid body is infinity. Greater the value of Young's modulus of a material, larger it is elasticity. Therefore, the steel is more elastic than rubber. Shear modulus. It is the ratio of shearing stress to the corresponding shearing strain developed in the body. G is equal to F upon A upon del X upon L is equal to F into L upon A del X is equal to F upon A tan theta. For very small angular displacement theta, tan theta is equal to theta. Shearing stress sigma s is equal to F upon A is equal to G into theta. For most material, G is equal to Y upon 3.